All right, let's dive into a concept that, believe it or not, is running the show behind everything, from a simple coin toss all the way to quantum physics. It's this invisible force that kind of shapes our decisions and our destiny. It's probability. So let's get into how we, as humans, finally learned to speak its language. It's a question we ask ourselves every single day, in a million different ways. A soldier who's aiming at a target, a scientist looking at atoms, a gambler just rolling the dice. If you dig deep down, they're all asking the exact same question. Because think about it, long before we had any kind of formulas to calculate the odds, and way before we built entire fields of study just around the idea of prediction, there was just this fundamental human condition, this simple, kind of unnerving fact that we just don't know what's going to happen next. Probability, really, is our grand attempt to make some sense out of all that chaos. So our story doesn't kick off in some stuffy university classroom. Nope. It starts out there in the real world, where probability was a tool that was born from practice, long before it ever became a theory. Just think about it for a second. Ancient gamblers didn't have formulas, but they absolutely had a gut feeling for the odds. Merchants couldn't run some fancy risk analysis model, but they knew how to weigh the chances of a ship making it back to port safely. Astronomers used patterns to predict when things would happen in the sky. All of them were using this intuitive form of probability, something born purely from experience. But eventually, the mathematicians got involved, and they asked what seems like a really simple question, but it's actually a deeply dangerous one. What is probability really? And the fascinating thing is, they didn't just land on one single easy answer. Instead, three totally distinct answers popped up, each one with its own philosophy. Now, it's important to get this. These aren't just different formulas. They're basically competing worldviews on what chance even means. You've got the classical view, which is all about pure logic, the frequentist view, which is all about data from repetition, and the subjective view, which comes down to belief in information. Let's break each one down. Okay, first up is the classical interpretation. This is probably the one you learned back in school. It's super clean, it's logical, and it works perfectly in these idealized, perfect situations. The key thing to remember here is that it assumes every single outcome is equally likely. And this is the perfect illustration of that idea. For a perfect six-sided die, there's only one outcome you want, rolling that 6 out of 6 total possibilities. So the probability is just 1/6. Simple, perfect, totally classical. But what about when things aren't so perfect? Well, this is where the frequentists come into the picture. They basically argued that probability isn't some abstract idea in your head. It's something you actually discover by doing experiments. It's not about logic. It's about repetition and just watching what happens. Now, what's so cool about this slide is how it shows the law of large numbers in action. With just 10 coin flips, the results can be all over the place. Maybe you get 7 heads, but as you ramp up the trials to 1,000 or even 1,000,000, all that randomness starts to cancel itself out, and the results get closer and closer to the true probability of 50%. For a frequentist, this is how you find truth, not through pure logic, but through just a ton of data. Then came this third, much more modern idea. What if probability isn't even a property of a die or a coin at all? What if it's actually a reflection of our own minds? This is subjective probability, and it's basically a measure of our personal degree of belief based on whatever information we happen to have. And this, right here, is where probability becomes incredibly powerful. It lets us tackle these really complex, one-of-a-kind events. You can't use classical logic for the stock market, right? And you can't rerun tomorrow's weather a million times to see how often it rains. For these kinds of problems, probability becomes a statement of confidence. It's an expert's belief, informed by all the evidence they have. So what we're really seeing is that probability wasn't just discovered in a single eureka moment. It evolved. It grew from a gambler's simple hunch into one of the most powerful tools humanity has ever created. The journey of this one idea is kind of the story of human understanding itself. From the gambling tables of the ancient world to the very first formulas in the 17th century to becoming the bedrock of the scientific revolution, and now it's fueling the entire data age we live in today. Each one of those definitions we just looked at is a mirror of how we've learned to understand our uncertain world. And that really brings us to the most important thing to take away from all of this. Probability is so much more than just a branch of math. It is the actual language we've developed to describe, to navigate, and to make sense of a world that is, at its core, fundamentally uncertain. So, we're left with this thought. In a world that is defined by what we don't know, this language is our single most powerful tool. It's more than just math. It's our systematic way of turning all that uncertainty into real insight, of turning chaos into some kind of order. It is, in a very real sense, the only way we can even hope to predict the future.